Our first word today is perpendicular lines, which are lines that intersect to form right angles. So perpendicular lines look like this, except they're straighter, but you know, such is life. And they intersect to create right angles. So you should have a right angle sign at each one. Parallel lines are lines in a plane that do not intersect. So lines that never intersect, two straight lines. And your sign for parallel lines is this. Skew lines are lines that lie in different planes that are neither parallel nor intersecting. We will talk more about those later. Adjacent angles. Angles that, oh, and your perpendicular sign, sorry to just kind of go off track, but there you go. Adjacent angles are angles that have a common vertex and a common side, but no common interior points. So adjacent angles would be something like this, where you have two angles right next to each other. Okay, they share a common vertex. This is their common side. All right. Vertical angles is a pair of opposite congruent, remember congruent, same shape and size, angles formed by intersecting lines. So we have something like that. Okay. Your blue are vertical angles, and then your green are vertical angles. Okay, so they have equal measure to each other. And a transversal is a line that intersects two or more lines. So it could look, most of yours are going to look like that. Okay? So, example 1 says to tell whether the lines appear parallel, perpendicular, or skew. So, U and V. UV, I'm going to highlight that back here, and YV right here. Okay, so the lines appear to intersect to form right angles. So UV is perpendicular to YV, sorry. So then let's look at the next two. We'll do these in red. XU, which is right here, and WZ, which is right here. The lines are in different planes and do not intersect. Okay, one's going up and down at the back corner of a cardboard box, and one's going left or right at the top corner of a cardboard box. So there's no way those could intersect. So they are skew. Okay, now we could look at one more, and we could look at, let's look at line YZ and line XW. Okay, so YZ is here, XW is here. They're both at the top of our hypothetical cardboard box, and they will never intersect. So line YZ is parallel to line XW. Okay, these next problems I think are great fun, but not everyone agrees with me. So we learned that vertical lines, or vertical angles, are angles across from each other. So 6 and 4 are across from each other. 50 degrees and 5 are across from each other. 130 and 2 are across from each other. And 3 and 1 are across from each other. So all those ones with the same colors have the same measure. So angle 2 and the one, we are looking for angle 2 though. Correct? So angle 2 is green, and we know that the other green is 130 degrees. So they are vertical angles. I should make that in green because those are in green. Let's actually go ahead and do that. So it's still vertical. I just want to make it the same color so you know what we're looking at. They are vertical angles. So since vertical angles are congruent, the measure of angle 2 is also 130 degrees. Now we are going to try and find the measure of angle 3, which is right there. Okay? Now, if I have a transversal, which is these two parallel lines, that is intersected by a third line, I have what are called corresponding angles. Okay? And corresponding angles are the following. Our corresponding angles, I'm going to put arrows to them in the same color because it won't allow me to erase, are angle 3 and 50 degrees, angle 2 and 4 degrees, angle 6 and 130 degrees, and angle 5 and angle 1. Okay? So, we need a G at that end of corresponding. Since corresponding angles are also congruent, the measure of angle 3, since they're both in yellow, we know the measure of angle 3 is also 50 degrees. Okay? And we're actually going to look at number 2 on the check it out together. Anytime you are given a transversal with 2 degrees, so on this one we have 45 degrees and we have 135 degrees, every single angle is either going to be 45 degrees or 135 degrees. That's just the way it works. Okay, so we're looking for angle 4. So we have angle 6 and 135 are going to be congruent. 5 and 7 are going to be congruent. 4 and 2 are going to be congruent. And 45 and 3 are going to be congruent, right? But you might think, well, that doesn't really help me because 4 is opposite of angle 2. And that doesn't give me any information. Well, here's all you got to do. See if we can erase this now. Oh, look, it worked this time. My eraser wasn't working earlier. We look at the angle number right by our given angle. So our angle number by 45 is 4. Now those two angles lie on a straight line. A straight line or straight angle measures 180 degrees. So out of our circle, we take the degree measure we know and we subtract it from 45 and we get 135 degrees. And that tells us what our own unknown measure is. Okay? Also, if you know that they either have to be 45 or 135 degrees, you know that angle 4, just by looking at it, is an obtuse angle, so it has to measure over 90 degrees. However, sometimes it will not be so obvious. So sometimes you might have to look at the given angle and the angle right next to it on the other side and do 180 minus 135 in this case, and you get 45 degrees, and that tells you that angle 7 is 45 degrees. Okay? Now that you have that much information and you know this is 135, you know that angle 2 is 135, you know that angle 3 is 45, you know that angle 6 is 135, and you know that angle 5 is 45 degrees. So even when they only give you one angle, you can find all 8 angles. You just have to subtract one of the given angles from 180, and that gives you the degree measure of the unknown right next door.